Everybody, welcome back to a brand new video of PJ Codes, and in this video we're going to do another LeetCode problem called running sum. Basically what this problem is we have a function called running sum that takes in an array, and basically it's going to output us a brand new array with basically a running sum of the elements within that array. Okay, so for example 1, 2, 3, 4 is going to output us 1, 3, 6, and 10, and that's because so initially what we want to do is just return our very first element in the array. So for our very first element, we're just going to return it, okay? And now for our second element, what we're going to do is we're going to add itself plus the preceding element. All right, so we get 3 because 2 plus 1 is 3. Okay, and then for the next element after that, we have 3. We're going to return 6 because 3, we're going to add the current element plus the preceding element. So 3 plus 2 plus 1. Okay, so that's 6. And likewise for 4, we're going to get 10 because 4 plus 3 equals 7. 7 plus 2 equals 9. 9 plus 1 equals 10. Okay, so pretty simple, and same with these guys here. Okay, you can just pause the video and just go through these real quick. All right, so let's begin. What we're going to do now is let's do running sum. And that's going to take in an array called nums, okay? And then what we're going to do is basically, let's just run a comment. So, all right, so what we're going to do is we're going to need, so this is going to be a pretty brute force solution. We're going to do a brute force solution first, and after that we'll look at a very optimized version that I found on LeetCode. Okay, so basically when I first did this, I just did a brute force solution. I know it's an easy problem, but I never actually optimized it myself. Okay, so, but let's just go into it. So let's do let sum equals 0 because we're going to need some sort of integer to basically just track our current added value, right? So we have that, and then now let's do let previous elements equal empty array, because what we want is basically an array to store our previous elements inside. Okay, and we're gonna have another array called results that we're gonna the result that's going to be basically our output. Okay, now what we want to do is we want to write a for loop. We're going to do let I equals 0. We do I is less than nums dot length. Okay, and we're going to iterate up. Okay, the reason we want a for loop is because the reason we're going to loop here is because obviously we need to loop over every element inside this array. Okay, and then we're gonna do some logic inside there. All right, initially what we're gonna do is we're just gonna push each index into our previous elements array. Okay, so we're gonna do private elements dot push nums I. Okay, so we're just gonna push every element inside our previous elements because we want to basically track all our previous elements. Okay, so we're going to use that array just to do that. Okay, and now we're going to do result dot push. All right, and inside this array we're going to push in basically what we're going to do is we're just going to wrap everything inside parentheses so it's neat. We want to take our current element nums I and then add it to the previous elements. So we basically want to add it to the sum of the previous elements. Okay, dot reduce. I'm going to use the reduce method for that. So let's just expand that out a bit. Dot reduce, and we're going to take in. So the reduce method basically takes in 4 arguments. And the last 2 are optional. So the first 2 options parameters, excuse me, are the accumulator, which is A, and B, which is the current value. Okay, and the second 2 are the current index and the source array, but we don't need those right now. So let's just return A plus B, which is our sum. Okay, and now what we're going to do is outside of reduce, we're just going to subtract back our current current index. Okay, we're going to subtract our current index. I think I might be missing a 13610. Okay, and now for this guy again, we should get 346. There we go. And likewise for this guy here, we should go into 345. Okay, so this is a very brute force solution. I didn't actually try to optimize this on my own. I just didn't have the time to. However, I did find a pretty neat LeetCode solution for it. This guy wrote like literally like a one-liner. So let's do optimize, and basically what we want to have here is basically what we want to have is a function called running sum, right? And you're gonna love this implementation. Nums, okay. Take some nums, okay. And then basically what we're gonna do is we're gonna take the reduce method. We're gonna do reduce, and basically we're not even doing a for loop at all because we don't even need that for loop, right? Because we can just use the reduce method to keep adding our current element inside the array using like plus equals into the accumulator. All right. So let's do, so the reduce method again takes in, traditionally it takes in 4 parameters. So the first one is accumulator, right? A for accumulator. Second one is the current value. Third one is the actual index, okay? The current index. And the fourth one is your actual array that you're passing in, okay? So what we want to do is take in our current element from our index and do plus equals a. That's it, okay? And then we're just going to do return. We're going to return nums, okay? And actually, you know what? Let's running sum. This should give us 1, 2, 3, 4, 1, 3, 6, 10. Excuse me. Same with this guy. Same with this guy. This should give us 3, 4, 6, 6, 17. And same with that guy here. 1, 2, 3, 4, 5. There we go. So yeah, this is the optimized. As you can see, way less code than this guy here. And that's what we want to do is basically initially we want to, it's okay if you initially come up with a brute force solution. That's totally fine. But what you want to aim for is something like this, right? You want to aim for something that you right off the bat that you just know is, is fewer lines of code, is a lot more scalable and reusable, and basically something that saves a lot of time, right? Because the way you even come up with such an optimized solution is by really practicing. You have to just keep practicing, right? And that's how you get better. And another thing I want to mention is that in the real world, in the professional world, you're not going to have time to always, write a brute force solution for a problem and then later on optimize it. You're just not going to have time because deadlines and all, things move quickly. So you want to right off the bat, at least think out the problem as well as you can. And I'm not saying, shoot for the optimized solution. In technical interviews, it's very hard to come up with an optimized solution because, on your first go, because you're under pressure, you have like literally 15 minutes, sometimes 10 minutes, 15, 20 to solve a problem. So in a technical interview, it's still okay if you come up with an optimized solution, a brute force solution first, and then you can, then if you have time, you can kind of talk through and, explain a more optimized solution to the interviewer. But in my personal opinion, you want to shoot for something that's that looks optimized, because that's only going to come with practice, right? So yeah, I just wanted to share this with you guys, and hopefully this helps you guys in really understanding how to take a problem step by step. And although this is not a bad solution, but look at the lines of code. This is 10 lines versus 2, right? So this is the difference between a brute force solution and an optimized solution. So this is what we always want to shoot for. All right, so yeah, hopefully this helped, and I'll catch you guys in the next video.